dog. Alrighty. Mr. Gatekeeper here. Hello, Mr. Weedpatch. I believe that's what you go by, ain't it? Let me see here. Yeah, Mr. Weedpatch. Well, basically, Mr. Weedpatch had ran this Texas Star 667. Actually, let me go ahead and get all the parts over here. I always like to kind of just show all the parts that came out of it, so you can kind of get an idea. Alright. And your top lid is somewhere outside the curtain walls there. So anyway, so basically Mr. Weedpatch sent me over a Texas Star DX667. Okay. He had driven it a little bit too hard. Got this cotton picker very, very hot. So hot that it melted some solder in areas, which created some cold solder joints. Both of the 1000 picofarad metal clad capacitors were laying down on the transformer. That's when you know you got that thing very, very hot. So he basically wanted to send this thing to me and just get me to go through it and just do the whole workup to it, man. Dual fan kit. Basically he cut me loose. You know, sometimes people will send repair work and they'll just give me the exact thing they want done. You know, number 1, number 2, number 3, number 4, whatever. And then some people will give the numbers of what they want done, but then they will add this, something like this. Do your thing, or do whatever you feel is best. Or, you know, something along those lines, and basically they want me to do whatever I want to do. You know, whatever I feel like doing that day, or, you know, just basically letting me loose on it and just doing my thing. So that's what he wanted me to do here, and he basically let me know how much he could spend. So we used that dollar cap so we wouldn't go above it, or at least not too much above it. But anyway, so what we went ahead and did was the dual fan kit. Okay, and this is my upgraded current version of the dual fan kit, meaning it has a, well, I've done something actually a little different this time that I haven't done before. Let's see if I can't get in here, and let me turn my headlamp on, see if I can't get some light in there. I don't know if you can see that. There it is. See that right there? That is a high-low switch for the fans. And if you kind of look down in there, we've got a big power 25-watt power resistor in there for the low. But the cool thing with this switch, it is a double pole double throw switch that is an on off on. So up is high, okay, the middle is off, so you can turn the fans off with the amp still on, and then all the way down is low. And the cool thing about it, when you turn this all the way down, you can't even hear the fans, but it's still pushing some good air where you can put your hand back here and just feel that air flowing through that heat sink. And if you plan on really getting on the mall good, you can put that bad boy on high. Okay, so that is the fan kit, which is plugged in right here. Okay, we've got enough inductance, some high permeability core there to help keep that RF off the fans, and each individual fan also has dual cores on it as well. Alright, here's your top, and this is the first time I've actually ever done this. I've got another guy I'm going to be doing this for here soon too. Basically putting the fan on top of the lid, because as you know, the most important part about keeping these cool is to keep the heat sink cool. But there is nothing wrong at all we're keeping the components here on top cool as well. It's not a must. Okay, let me repeat that. It's not a must, but it definitely is not going to hurt anything. You know what I'm saying? More air, the better. So we have done him a single kit. I mean, I could have went crazy and done a dual kit, you know, which is very possible. You know, it can be done, but there's really no reason to have that much air flowing through the inside. But hey, it's all preference. But I went ahead and did him a single kit, and this is a blue LED fan, because I could tell he likes blue LEDs with another request he made. So there you go with that. And I don't have this wired up yet. I'm going to wait until I get done. Well, I'm gonna solder it here. See, what basically I've got the fan on top on a regulator. Being an LED fan and being sensitive and all, I'm gonna be hooking up on unregulated supply. Me putting this regulator on here mainly is for me, but if you know, it's for him too if he ever hooks this thing up on an unregulated supply. And let me tell you, if you do, I do not recommend running this thing on an unregulated supply, which I know you're not going to be. You've got a power supply for Mr. Danny, a 1, 2, 3 that you're going to be running this on. But if you ever do decide to run this on an unregulated supply, which again I don't recommend, you need to put that fan switch on low and keep it on low. Okay? You put it on high, you will fry the fans. I really don't know how much protection you'll have on low, but if you absolutely have to, put it on low. But like I said, just don't do it. I have to, because I don't have a real big power supply here to show you what you want to see with this thing. I know you want to see it really getting up and going, so this little servo supply is not going to be able to handle that. So anyway, let me get going to the next thing here. So of course he wanted the full power wire upgrade all the way to the back of the transformer. So like I always say, it don't make no sense to put these big thick wires on here just for it to connect to this little bitty choke here with this super tiny solid gauge single conductor wire, single gauge wire, conductor wire to feed the back of the transformer. Don't get me wrong, this is adequate, or Texas Star wouldn't have used it, but there's definitely nothing wrong with taking this and almost quadrupling the thickness of the wire right there from here to here. You want this thick because this wire right here, I need to put a tie strap on this right here so it won't be moving around. That's one thing I need to not forget to do. I put a little tie strap right there before I put the top on. But because you're going to have thick wire, you don't know how long this wire is going to be. And as you can see with the fan kits, we remove the fuses. These fuses are some current hogs. Well, I won't use the word hog, but this right here will give you voltage drop. You're dealing with two surface connections, meaning a surface connection on this end of the fuse and this end of the fuse, and you're dealing with a high current here. Texas Star uses these to be electrically politically correct, and there's absolutely nothing wrong whatsoever with removing them like I do. But if you're going to run this in a mobile, it is a must, and I repeat, a must, to run a fuse at your power source, meaning at the battery. Okay, these right here are two 35 amp fuses. Okay, so put you a 70 amp fuse on the power bus. If you want to, you can go down to a 60 to be extra safe, and if you keep popping it, then you can upgrade, up it to a 7, because I know 70 is an odd number. You can go with a 60, it should be fine. But yes, but the cool thing, if you're running this in-house on a power supply is going to have protection on it. If something ever goes wrong, the power supplies will shut off. But there is nothing wrong with you running the fuse in-house to the power supply as well. There's nothing wrong with that as well. Use some big Hawking fuses though, not small ones like this. Use some big Hawking fuses, AJCs or big cylinder type fuses, something big, so you won't have that voltage drop issue that you do have with these. Okay. So we did a full power wire upgrade all the way to the back of the transformer. This is 14 gauge wire, 3 wraps, That gives you right there about equal to the well, actually just a tad bit more inductance than what these two chokes right here was giving you. Sometimes I'll throw a little extra wrap in there if I can fit it. Alright, next thing is he's going to be running this with a Yazoo 101, I believe it is, which is not going to work with a 667 unless you put some attenuation in there. I've seen other builders like Mr. BBI, Mr. Luke Miller, I've seen him add some attenuation in Texas Stars before, which was a pretty cool idea, so the person can run a hot radio, and they can also run their smaller radio too by utilizing the green switch there, which is a pretty cool little idea. But we went ahead and converted this whole amplifier over to a Texas Star 500V. So that's what this is doing out. This is the driver circuit. I don't even know if this transistor is good or not, but we'll test it later. So I can add that to the bill there or whatever. Alright, so next is I checked your variable, and luckily it was still good. Of course, we went ahead and put you a brand new front on here, Texas Star 500 front, a brand new meter. Okay, I had to replace a bulb in this one right here. The bulb was working, but it was weird. It was working sometimes and not working sometimes. I think the filament was like just right there hanging on, I guess, because there's nothing wrong with the internal connections over here. So I just replaced it to be safe. And of course, I went ahead and did my my normal little modifications, slash TLC work, I guess you can say. Soldered all my tabs right here, so in the future you'll never have to deal with an issue with not making good contact. Thickened up the solder right here on the output where the power comes in and flows back this way then to the relay. I fixed a couple cold solder joints. This tin, okay, see, we had two issues with this amplifier that I had to troubleshoot. Now, I have worked on hundreds of Texas Stars since I've been doing this, hundreds, and it blows your mind because every once in a while you'll see something that you've never seen before, as in troubleshooting and fixing something that you've never seen before, right when you think there really couldn't be anything else that could pop up that you haven't seen. But it always seems to happen. And the funny thing about it is it's happened the last two Texas Stars in a row that I've worked on. So the first thing, man, this thing had me just scratching my head here, was the second that I flipped the power switch on. Okay, because you learn some troubleshooting techniques when you deal with Texas Stars. Because one thing you have to understand, when you turn this power switch on, the lamp in here, which does not have continuity, is usually somewhere around 40 to 50 ohms on an ohm meter. So when I do this right here and I'm reading from power to ground, I should see about a 50 ohms worth of resistance. Okay, and that's just letting me know that that lamp is working. When I go ahead and press this one in, now we have two lamps in parallel. So it's going to start going down, down, and down. So that's a good way to really, I'm not trying to have a lesson here, but that's one way to check your lamps. But it's also a way to do some other troubleshooting, because the problem I was having, as soon as I turned this thing on to check the bias, this 10 microhenry choke went up in smoke. And that can be a number of things, usually about 3 things to be. I ain't going to go through and list them, but we have now added another thing to that list if that 10 microhenry choke goes up in smoke. I went through all my normal troubleshooting to see what it was, and it wasn't none of them. So I started to, once I removed this 10 microhenry choke, the connection right here that it connects to was showing a short to ground. And I was like, okay, well, up under the board is touching the frame. Well, I do it like I normally do and take me a piece of plastic like this, and I start going up under the board like this to see if it stops. So it tells me 100% that's what it is. So then I can go ahead and remove the board, fix it, or whatever procedure I choose to go with at that time, and that wasn't doing it. that wasn't doing it. And it had me really scratching my head here because I had never had this happen before, ever. So I started going through this thing and just doing almost every troubleshooting technique that I know, that I have written in my Texas Star Book of Knowledge that I've been adding on to all these years. And I want you to know, man, well, first off, I don't know why this relay didn't have the plastic top. But it was a telltale sign to me, you know, why does this relay not have the top? I noticed when this relay was sitting in here that I could move it a little bit this way and the continuity would stop. Because when I have a dead short like that, I'll just hook my voltmeter up and just hear that beep and just sit there and just listen to it till I fix that short. Because when I fix it, that thing's going to go off. Or for dealing looking at the lamps, if I fix it, I'm going to see that 40 to 50 ohms worth of resistance. Okay, so anyway, I'll try not to bore you and get all the details, but come to find out, this relay, the contacts was shortened in areas that this relay is not even supposed to be connected to. What had happened is you had ran this box so hard and it had got so hot that the contacts in two of the contacts inside the relay had fused together. Okay, which you know, I've had this happen a lot, but I've not had one fused together in this manner before, ever, in a Texas Star. That's why it threw me for a loop there for a second. You know, I probably have 4 to 5 hours just in troubleshooting just with that. That's how far it had me for the loop, man, because you do all this stuff and you're so used to it being this or that and this or that. When you're about to hit up a new issue, sometimes it takes a little while. But see, now in the future, I'll know what to be looking for when that happens. So I had to remove the board, which I hate having to do with these things, but sometimes you got to do it. I had to remove the board and install you a brand spanking new relay. Okay, and just to be on the safe side, I went ahead and put an insulator up under the board right there at the relay point and over here in this direction too, because these boards can warp. And that's what I'm about to tell you about the second issue I had. Okay, as these boards get hot, cool down, hot, cool down, hot, cool down, they can begin to warp. Okay, this board right here had a dead short, and this is what I don't understand, how you did not blow these transistors, Weedpatch. I have no idea how you didn't blow these transistors. Now, I did not go in here and check these fuses to see if they're blown. Maybe they're blown and that's what saved you, but you had a short up under the board on the hot side of this board to ground, my man. Now, I mean, it could have been done during shipment or what. So what did old Gatekeeper have to do? After he had just got done removing this board and putting the board back and soldering everything back in place, yes, then I had to remove this cot picking board. That's what I'm saying. You know, I was like, well, dang, if I'd have known that. This is one of them type of repairs to where you have dual problems, but the second problem is masked with the first. You can't see the second problem until you fix the first problem, because there were two things, in a sense, shortened to ground, you know. And you know, this right here is connected with the RF on the bottom on the output, so when it shorts to ground, you have an RF short too. Oh boy, so it was a bit of labor intensive right there, man. So we went ahead and fixed all that. Went ahead and put your new tuning cap on the input of here, since it's now a 500. Put your new filter caps right here on each hot bus. Went ahead and add you 1,000 right here, 1,000 over there, another 104 right here, 104 over there. And let's see if we don't miss anything. I don't want to leave nothing out. I believe that's it. I believe. If something else pops up, or if I remember something. I know there was a couple of cold solder joints. This end right here had a cold solder joint on it, which I had to fix. And yeah, I did the 1000s. Of course, I had to change this resistor right here over to a 1.8. And there was another cold solder joint somewhere, and I can't quite remember exactly where it is. Alright, on to the last thing. Mr. Weedpatch wanted the blue meter modification. Now, I've done this a few different ways in the past. You know, I've went all the way to where I drill a hole in here and mount a single LED in here, and, you know, a couple of different ways. And sometimes I like to just kind of switch it up and try something new. So I tried a new way right here that I actually like. I actually like this because this right here is copper wire, solid copper wire, so that it can support these LEDs. And as you can see, it is supporting them good. But the way that I position this just perfect is when I put the LED in there to solder it, because it's exactly where it's at, it actually would hold the LED for me against the meter, so I could solder it in. And then of course, you know, we just use some simple Ohm's law calculation to see what size resistor we would need. And it just so happened to be a 100 ohm resistor, since we got 7 LEDs. That puts these LEDs right there at about 20 milliamps, if I remember correctly. So each LED is getting 20 milliamps each, and that is dropping the voltage from 4.5 volts to exactly 3 volts even. 3 volts even, or is it 3.5? I may have done 3.5. I can't remember right offhand. It's 3.5 or 3, because I wanted these LEDs to be absolutely as bright as possible. That's why I did that. Whew. Alright, man. Well, let's let you see this thing in action, big brother. And I think I already showed you over here. That's all the parts that came out of it. Okay. Yeah, I did miss something. I went ahead and put your new 1200s on the input transformers here, because I pulled one of the 1200s and it was reading right there, like, it wasn't bad, but it was reading about 100, a little bit over 100 picofarad less than this one. So I just went ahead and matched 2 of them. Well, I actually already have them matched, pre-matched, and put your 2 new 1200s right here. That's what I was just looking for. Where's the other 1200 I removed? When you're sitting here working, man, these things will fall on the floor sometimes. There's the screws that came with it. I'm giving you some new screws. My good buddy over at Texas Star helped me out not too long ago and hooked me up with some good screws there. I love using Texas Star OEM equipment to repair Texas Stars. I really do. I like to keep it the way it looked normally if I can, to where you can't really even tell, you know, something was changed. Alright, let's go ahead and fire this bad boy up, get it hooked up, and let you see this thing working. The only other thing I do need to tell you, both of these SO239s are a little loose inside. That can happen with heat. It really can. I went ahead and cleaned the inside of this with some acetone, and went ahead and bent them back very carefully so it can make a little bit better connection on the PL259s. Okay, so let me get everything hooked up and we'll be back. Alright, brother, we got it hooked up to the bench radio, which is under here. Okay, I'm just going to leave that radio mounted up under there. I got my other radios up here, my hot radio, Stickman modified. I got the big monster derail radio, ranking in at 16 watts RMS. Actually does a little bit over 19, and that's a Superstar 158. I'll use that on preamps stuff and sideband stuff. So there's your fans coming on. Alright, like I always said, if you can't make a Texas Star 500 do 500 PEP watts with my bench radio, which is driving 4 watts RMS, about 18 to 20 watts PEP, then something's wrong. So this is all the way up, green button in, we got the variable turned all the way up. When you turn this up, this utilizes this 75 ohm resistor you see right here, okay, in conjunction with the variable. Okay, it gives you an attenuator, 500 watt slug. This is PEP. Oh, off the scale. Input reflect, 5-watt slug in reverse. Oh yeah, absolutely unbelievably beautiful input tune. Oh yeah. And of course, if you press this green switch in, now this is the way that you would run this amplifier on a high drive. Okay, if you're ever going to use this amplifier right here just with a radio like I just did, you can engage this dial-a-watt here and adjust this. Now if you're going to use this as a high drive, you're not going to want to do that because you're going to be putting too much stress on this variable. Okay, so if you're going to be using this like with a driver or something, which, you know, I don't recommend, but you can if you want. I mean, that's what a 667 is. You got a driver built into there. Then you need to turn that off. Okay, just to be safe, because you're going to put too much stress right there. And of course, on high, go off the scale. This thing's doing probably up to over 600 peak watts. I mean, this thing's smoking, man, smoking. And that is the voltage that we're on. Just 14.2 volts. Here's your RMS. This is the 500-watt slug. So we're reading the middle scale. Go about 180 watts bird, just hitting it with the bench radio. Go right there about 180. All right, man. I know you want to see this thing get up and get to cooking. And oh yeah, there's the blue LED. Look at that thing, boy. That thing's lighting that thing up nice. Oh, now I didn't put a LED down here, which would have lit the whole thing up. What I kind of had the idea about this, if you'll notice, your regular lamp is lighting up too. You see that? So I was going to basically utilize this to where it's going to light the. It's still going to light it's still going to light the meter up, but it's also going to light up with green, kind of at the, with blue up at the top, kind of with a fade downwards. You can't really tell since I got the lights on, but you see what I'm saying? So you can still look in there and see everything. Cool little twist. Cool little twist. Alright, so I have not yet hooked my Stickman radio up yet since I've done all these modifications in here, so I'm about to go ahead and do that now. And I guess I have to go get my 1-pill driver, huh? And I'm sure I could probably make this thing do a kilowatt just with the old D-rail radio. But I don't think I'm gonna hit this radio with a D-rail today. That's for the bigger amps, fellas. I'll be back. All right, we got the Stickman Cobra 29 hooked up. Just to let you see, I don't even know if I showed this much. Now it's doing a little bit less than 8 watts RMS because it's going through a lot of cables here, but we got the 10-watt slug in there. So it's doing about 7 watts RMS. It's losing a little bit through all these cables, which is understandable, but it does right there. I got it set right there at 8 watts. I guess if I wanted to, I could turn the voltage up just a tad bit. That's how I like to control these radios, with the voltage, to give them, you know, up and down. So now I got to hook this up to the unregulated supply, which I kind of hate doing. And I'm going to kind of just get in here and just kind of quick do this. The reason why is everything is safe, but we've got the LEDs here set to where these things will be bright as they can. So it ain't really current limited for that high amount of voltage, but we should be fine. So I'm just going to kind of just do some quick keying for you. I ain't going to stay on the mall, and I know you want to see what this thing really can do. And I will be getting me a proper power supply regulated here soon. Alright, be right back. Let me get the cables hooked up and this real deal, Mr. Real Deal 100 amp supply hooked up. Be right back. Alright, big brother. We got the 1-pill epoxy 1-pill driver hooked up. Very first amplifier I ever built. Had everything glued down with epoxy, trying to drop the solder on each connection. Didn't know what the heck I was doing. I will always keep that amp. I got the unregulated supply on. I actually have it on the medium tap. She's floating at 18 volts. And as you're about to see, she's going to drop down to about 13.5. But look what it gives you. Now this is the Stickman radio, driving into the 1-pill driver, then into the 500. 1,000-watt slug. This is peak first. PEP. Go 1,000 watts, man. 1 kW already. And that is only on go 13.4 volts. Let's see what she's doing bird wise. Reading 100-watt scale. We're looking at the bottom scale. Oh my goodness! You have got to be kidding me! How in the world is that cotton picker already doing over 400 bird on the medium tap? You have got to be kidding me! Golly! Oh, look at that! This cotton picker is smoking. 450 bird. Just hitting it on the medium tap cotton picker. Goodness gracious. I've got to burp it at least one time on the high tap. That is unbelievable. Usually, I don't know if you've seen other videos, usually at this point it's usually doing around 300, 350 bird. Not 450, man. This thing is smoking, son. Goodness. I'm just going to burp this real quick, y'all. Real quick. Do not run your Texas Stars like this at the house. Do not try this at home. 21.2 volt float. This is just a quick burp. I just want to see what that cotton picker's on doing the high tap cotton picker. Go. Woo! Over 500 bird cotton picker. I didn't even get to look to see what volts it dropped to, and I don't care. I ain't keying it again like that. If it was my box, it'd be different. Hey, Weedpatch, I think this cotton picker right here is ready to go. What you think? Let me go ahead and press stop on here and get this top put on and mounted. We're gonna fire the regulator supply up one time just so you can see what she looks like with the top on it. Be back. Alrighty, brother. She is all done. I always love seeing these things when I get done with them. God, it looks so beautiful. And can y'all believe I haven't took the time to actually make myself one yet? Alright, here we go, man. Yes, sir. And you're probably wondering where's the air going to that's blowing down in here. Well, I didn't have to worry about drilling any holes on the back like I thought I was going to do. There's enough air on the bottom of these switches right here that the air is going to be blowing in out this direction. So all your hot air is going to be blowing out the front this way from the top, and all your hot air from here on the back. Now I got the fans right here on the bottom actually on low right now, so you can barely even hear them. Here's your meter, a little bit darker. Oh yeah. Oh yeah. 1,000-watt slug. This is just with the bench radio, 14.5 volts. Look at this. Oh, right there at 600 watts PEP. Anybody watching this video, if you got a Texas Star, you might want something like this done, just give me a shout, and like my boy Stickman used to say, we'll help you out. Mr. Gatekeeper out here around the northeast end of Georgia. Another Texas Star repaired, back into the scene, so some talking can be done, you know what I mean. And we're good, and we are gone. Thank you, Weedpatch. Thanks for hanging in there with me, brother. I'm out. God bless.